So we'll get started then. So good afternoon, everybody. My name's Jim Barrett, and I'm the man standing between you and your afternoon coffee. So I'll try and keep you engaged. I'm here representing Klarna, specifically the AI and automation department within Klarna. And I'm going to be talking to you a bit today about the work we're doing to do with, automating web interactions. Now, I'm from the UK. I'm going to start this presentation off like a true Englishman with an apology. I had a reputation in my old life of having visually basic slides, and I don't think I'm going to do anything to dispel this reputation today, but all the information's there, and they're not crowded, so forgive me for that. Okay, so I'm going to start by telling you a little bit about who I am, who I work for, and how I came to be talking to you today. So I'm actually a physicist by training. As I said before, I'm from the UK originally, and I'm a physicist by training. I did my master's in mathematical and computational physics, and then went over to do my PhD in a gravitational wave group, where I kind of was halfway between a group which was writing very fast simulations, which is where I learned all my software, and a group doing data analysis on gravitational wave data, which is where I learned all of my statistics and machine learning. And as I was coming to the end of that PhD, the good people over at Klarna were coming up with this idea of putting together an organization within the company to work on web automation, which I'm going to define properly in a moment. As I was coming to the end of my PhD, I saw this advert from Klarna. They were looking to assemble a sort of diverse group of people with a sort of diverse set of backgrounds in order to work on this problem of web automation. They were looking for people with experience in software engineering or machine learning, which I had a bit of both. So I applied, and here I am. We're now 16 people working on this, spanning 12 nationalities, with a huge variety of backgrounds, people with more or less pure software engineering backgrounds through to people like myself who have more academic backgrounds, and everything in between, people experts on NLP, experts on computer vision, and so on and so forth. So it's an awesome place to work. So yeah, that's a little bit about me. Without further ado, I'll just run through roughly what I'm going to be talking to you about today. I'm going to kick things off by giving you an example problem, a problem that we're actually trying to solve within our team today. I'll then relate that to this term web automation, which should become clearer as I go through the example problem. And I'll also talk a little bit about why we're using AI to solve this problem. I mean, I'm at an AI conference, so I guess it's kind of obvious we're using AI, but it was one of the topics in the keynotes, I think, yesterday, that AI, you should think a bit before you actually start throwing AI at every problem you've got, and I'll tell you that we did think about that and why we're doing it. I'll then change pace a little bit to the more technical, and talk about solving one particular small piece of the example problem that I'm going to start my presentation with, and talk about the types of data we have available to us in the problem of web automation, and using that to find a button on a web page, basically. And then I'll talk a little bit at the end about the challenges we're facing in the future research that we're going to do. So the business problem I pose to you is the following. So here I've presented 3 different cart pages from 3 different merchants. So the cart page, once you've clicked around and you've shopped, you end up on this page, which lists all of the products that you're ready to buy, right? And it lists the total price of your purchase, and then you'll click one of the buttons at the bottom there and go through and check out any of your credit card information and so on and so forth. Now, the problem that we'd like to solve is to be able to determine what the total price is, what the total value of our cart is on this page, right? Which, showing you these lovingly prepared cart pages, as I have here today, sounds really, really easy, right? I mean, so maybe you've got to discriminate between different prices on this page, but as humans, we look at this and it's quite easy to find, right? But I'm going to add a little bit of complexity to this problem, which is that all I'm going to give you is the URL of the merchant, right? So so instead of landing on a nicely prepared cart page, as I've got here, we're going to instead end up somewhere like this. So this is the home page of Dustin Home. As you can see, I don't know how does this work? Can I? Okay, yeah. So our cart is empty currently. There's no product in the cart. So I forgot to mention something. So I'm telling you about this problem, but I'm not telling you why we want to solve this problem. Now, looking through the speaker list and speaking to people at this conference so far, I think it's a largely Nordic audience here today. So many of you will probably already know who Klarna are and what we do. But for those of you who don't know, because I certainly wouldn't have known 9 months ago, one of the key, Klarna does a lot of different things. They're a bank ostensibly, but one of the key products that Klarna offers is credit products, right? And so if you want to buy something, you want to buy something expensive, you may want to defer payment, pay later, or slice it in Klarna lingo, by which I mean defer payment or spread your payment over an amount of time. So credit products like this, right? And in order to offer credit products, we need to perform credit checks, and depending on how quickly we want to perform these credit checks, if we want to do them in real time, that influences the complexity and the amount of risk that we can take as a company in offering these credit products. So if we're able to know where the total price is on the cart page as the user is browsing through the merchant, then we can spend more time performing these credit checks, do a better credit check, and so on and so forth. So that's why we want to do this thing. So going back to where I was before, so we don't have these lovingly prepared cart pages. We end up on the home page of a merchant. So let's break down now this problem of finding the total price on the page, starting from here. So it's tempting to just want to go straight to the cart page immediately, but obviously right now there's nothing in there, so there's not going to be a total price for us to find. So the first thing we have to do is pick a product, any product. So we have to navigate our way to a product page. Now, depending on the merchant, this can have varying degrees of complexity. But this is, generally speaking, sort of one of the easier problems we have to solve, because merchants, they like you to be able to find their products. It's tended to be fairly easy to find the products. It might involve a little bit of crawling, maybe a classifier to say, is this a product page or not? But this is one of the easier problems that we're faced with. So, okay, so we're on a product page, awesome. So the next thing we have to do is add this product to our cart so that when we get to our cart, there's a product in there, right? So that involves, as humans, this is really, really easy to do. Everything here is really, really easy to do as humans. These websites are designed for humans, but it means we have to locate this button here, right? And click it. So say we do that, and we successfully do that. We get a nice little bit of, the image has disappeared off the bottom there, but you can see the most important information here is that we've got this little indicator here that we've successfully added this product to the cart, right? As humans, we can verify that we've added this product to the cart. So all that's left to do is to navigate now to the cart. Again, super easy as humans. It means that we have to find this little picture of a van here and click on it. So we do that. We land on the cart page, which has now been prepared by this AI, which has now been prepared with a product and a total price, and we have to extract this total price here. I mean, so obviously total price is a slightly thorny issue on this page, but from our perspective, total price is the total price that the customer has to pay, including shipping and tax, and so on and so forth. So, to sort of speak in sort of more abstract terms, then what do I mean by web automation? What am I talking about in terms of web automation? It's being able to solve problems like the one I just solved, right? It's being able to start from a merchant homepage and carry out some complex workflow, add a product to the cart, and navigate to the cart and find out what the total price is of the cart, right? Web automation is teaching an AI to be able to do this. So the way that we're approaching this problem right now is from the perspective of teaching an AI agent, to basically constructing a tool set of like machine learning methods to be able to do the kind of sort of micro tasks that you need to do in order to navigate a merchant web page. Things like, which button is going to add this product to my page? Where are the product pages? Which button is going to take me to the cart page? What kind of page am I currently on? Tasks like this, and then the plan is to then sit an AI agent, a clever AI agent, on top of all of those, on top of that tool belt, in order to be able to sort of pull the strings and then conduct the kind of abstract workflows that I'm talking about, where you want to first find a product page, then add the product to the cart, then go to the cart page, then find the total price, right? So at this point in my talk, I guess you might very well be reasonably thinking, well, sure, you could train an AI to do this, but probably you could achieve really, really good results with just a cleverly constructed set of heuristics, right? Well, I mean, why throw AI at this tool immediately, right? And you'd be right. And we're actually been talking to startups and some other companies which have seen a lot of success using heuristics for this kind of problem. But Klarna is currently partnered with 90,000 merchants globally, and that number continues to grow. And we want to be able to do this kind of stuff, navigate the merchant website for all 90,000, or all, however many it is in the future. Many, hopefully. And we want to be able to do this for all of them. Now imagine just one, every so often one of these is going to change how their website looks, and our heuristics are going to break. And when you start looking at these kind of order 100,000 merchants to maintain, this becomes an intractable problem. It's just going to take too many person hours to do it. So this is why we want to try and build an AI to do it instead. On top of that, we anticipate, and we've seen, in fact, that there's a long and heavy tail of the merchant websites which don't yield the heuristics, don't yield the cleverly constructed heuristics, right? Or it takes too much time to, tailor your heuristics to these sort of home-brewed merchant websites that, a merchant has built themselves or whatever, not using a common framework. So we need to be able to scale to these large numbers of merchant websites, and that's why we want to use this AI. Another reason that we want to use this AI and build it in the abstract fashion that I've been talking about with building this tool belt of tools and AI sort of puppet master at the top is that I've only described one problem to you here today, but there's a wealth of more business problems that we could do. Things like logging into a user's account to check on the status of an order or something like that would be another example. And if you could aggregate that from all of the merchants that a user is dealing with, that would be very useful from a business perspective, right? Putting my old academic hat on as well, and kind of nerding out a little bit. This is a really, really cool problem, and it's not really been tackled to our knowledge in the way that we're doing it. We anticipate that we're going to be able to contribute real research to the community, and that makes me feel warm and fuzzy inside. So I'm going to sort of change pace a little bit now, and I'm going to talk about the specific case. So one of the steps in the process that I just described was finding that little picture of a van and clicking on it, right? So I'm going to go sort of take a bit of a deeper dive into how we're solving that specific machine learning problem. But in order to solve machine learning problems, you need every data scientist or machine learning engineer's best friend, which is the data, right? We need to leverage whatever data, whatever information we have available to us. So I'm going to enumerate some of the data that we have available to us for this problem. So the first piece of data that we have, and one of the more powerful pieces of data we have, is the code that the web uses in order to, collect all of the content to put on a page and arrange it on the page, right? I mean, we're a technical audience here, so I'm sure you already know the basics of HTML. But the most sorry, I got an echo then. I thought somebody was talking. So the one important thing I just want to point out is that HTML as a language is kind of a textual representation of a tree structure, right? So you have your web page, and in the web page you have a header and a body and a footer, and then within the body you have sections, and then within the sections you have subsections, and within the subsections you have other sections or content or whatever. Websites are sort of naturally represented as like a tree. And I'm going to be using sort of the shape and the topology of these trees a little bit later on in the talk, which is why I wanted to draw attention to that here. The other and kind of more obvious, I guess, information that we have available to us is the visual information. Websites are designed for humans to interact with, so we expect them to be laid out in a predictable fashion, right? So we can leverage the information that the user would see and allow the AI agent to look at that. And I'll speak a bit more in detail about that shortly. There are some other types of data available to us which are not so pertinent to the specific problem that I'm going to talk about in a second, but nevertheless could be useful for other problems. So you have like the HTTP request, the information that's sent to and from the web server. We can piggyback on that and have a look at that and see what that tells us. For the problem of working out what kind of page are we currently on, if it's merchant.com/product/1234, then we know we're on a product page. The URL itself can be quite a useful tool in deciphering that. This third one's like very interesting. I'll hark back to this at the end of my talk when I'm talking about future directions. So this specific problem that I'm telling you about now is just sort of an isolated tool on our tool belt, but we also have kind of this sort of action and consequence relationship, right? I click on a button that I think is going to take me to the cart page, and I land on a new page, something happens, and with some certainty I classify that page as a cart page, which tells me that I was right with the button that I clicked in the first place, right? So we have this kind of, experiment kind of setup here where we can perform actions, observe consequences in order to inform us as to whether the action we carried out was the correct one, right? Which is kind of alluding to the language of reinforcement learning, which I'm going to mention again at the end. Another feature we have is kind of the connectivity of a merchant website. Features such as how many clicks is it taking me to get to this page? Again, this would be useful in stuff like a page classification. Am I on a product page? If I'm like 2 clicks away from the home page, probably that's more likely than if I'm 9 clicks away from the home page. That might be a checkout page or something. Cool. So those are all the kinds of data available to us, and there's probably other stuff that we haven't thought of. So I'm going to run through this specific example, as I said, of finding and clicking on the cart button. So by the cart button, I mean the button that appears on most merchants on every page, which is going to take you to that list of all of the products that you're ready to buy before you check out, right? So I'll give you a high-level overview of how we solve this problem, first of all. So we start by, where are we? We start with our web page. And then we look through that web page and find a bunch of elements on that web page as candidates, things that we think could be the cart button, right? We then pass each of those through a bunch of different machine learning models in parallel, and each of those gives us a score, right? So each of these models will give us its best guess as to which of these candidate elements is the one we're looking for. We then aggregate the scores from all of these different classifiers, which eventually gives us of all of these candidate elements, which ones are the most likely to be the one we're looking for, right? So that's kind of the high-level overview, and I'm going to go through each of these steps one at a time. So the first step we have to do, given a web page, is find candidates for the element that we're looking for, right? So we actually don't, as a team, currently approach this as a machine learning problem. We approach it as an engineering problem because we can be quite permissive. We can have a long list of candidates. So what we currently do for the specific example of finding candidates for the cart button is we look for every element on the page and we say, is it possible to interact with this element, right? So that could be because it has a link attached to it, or it has a jQuery event handler attached to it, or it is literally a HTML button, and some other heuristics as well, which I forget. Basically, yeah, this gives us a list of all of the elements which we expect if we were to interact with that element, then something would happen, right? And then we move on to the actual machine learning part, or the bit that we're using machine learning for, is these classifiers, right? The things that are going to look at this element that we've chosen and tell us how likely is it to be the element that we're looking for. So I'll start by talking about using an image classifier to do this. So they say that a picture speaks 1,000 words. So I've presented to you more or less a book's worth of information, evidence here, that you can use what the element that you're dealing with looks like, right? So I've presented about 40 or 50 examples of elements which we have labeled as carts in our training set. And obviously we have a wealth of elements in our training set which aren't carts. And this is just simply a classical image classification problem, right? We wanted to look at the element that's our candidate and say, how much does it look like all of these elements which we know are carts, right? And this yields to sort of the cutting edge, or this sort of classical convolutional neural network approaches to image classification. So that's exactly what we do. So first of all, we crop a sort of small image of the element that's our candidate, and we feed it through a convolutional neural network, which we've trained on data like this, and a bunch of negative examples, of course, as well. And that gives us a score for how much the cart button looks like a cart button. So the next classifier we pass it through, the next model we pass it through is using context-based information, or I've called it position scorer on there. So sort of as a small exercise, if I ask you, all of you here now, to locate the cart button, your eyes immediately go straight to the top right, right? And it's actually a surprisingly strong feature that we found, is that just looking at the vicinity of an element to the top right-hand corner of the page is a very strong indicator as to whether it's the cart button or not. Turns out to be very powerful. But there's other sort of contextual information you can use as well. For example, so you can see the cart button up here. It's also very close to the login button in the search bar, right? It's the same. It's in the same kind of vertical position as the company logo, or roughly the same. And we can kind of utilize all of this information to build our confidence, this contextual information on the page, to build our confidence as to whether this is the cart button or not. So we feed it through a classifier here, or two classifiers actually in practice, this context and this vicinity to the top right. And that gives us a score for each element. How likely is it to be the cart button? Okay, and then sort of the third classifier I'm going to talk to you about today, that's a sip of water, is features coming from the HTML from this tree representation of the web page. This is actually very close to my heart, because in the kind of free research time that Klarna gives us when we're working on this problem, I've been focusing my efforts on tree-based features. It's a very interesting topic. We even have a master's student actually currently attached to our team who's researching very clever ways of compressing and utilizing the structure in trees to feed them into neural networks. But I was tasked in my research with trying to come up with cheaper and simpler ways of doing things. So the feature I came up with, so this is like an arbitrary tree. I've just made a random tree here and filled it with random elements. It's not so important. But I wanted to try and capture in a simple way the kind of connectivity and the shape of this tree. Topology, I guess, is a fancy word. So the feature I used here was basically to count the number of families in the tree. By family, by family here I mean trees which have nodes in the tree which have a common parent. And by counting these on each level, as it turns out, I was running a bunch of experiments during my research, and if you do this for a bunch of elements and take the logarithm of that number on the right, and put sort of these in a vector, so you'd have a vector of log 1, log 2, log 3, log 2. If you take that vector for a whole range of elements or a whole range of websites, these vectors are multivariate Gaussian distributed, which I found fascinating. I still haven't managed to come up with a decent explanation as to why that is. It's like what I'm currently working on amongst the engineering tasks. So we have these, we fed all of these candidate elements through all of these different classifiers. So one of the big challenges that we have with this problem is that the data available to us, we have this tree, we have these images, we have other information, is very diverse, and there's sort of diverse types of structured data. And we've been, this is all going to become a bit fuzzy between the current state of the art for us and the future directions, because we're looking at ways of trying to feed everything into the same model, right? But right now, we feed all of the scores, all of the kind of confidences coming from these simpler models into an aggregate model. And what we currently use for that is a random forest model, because we wanted something that's kind of agnostic to the scale and the kind of type of data with the scores that we're forcing into it. So we combine the predictions of each of these weaker models into an aggregate model. This is very much work in progress, the nature of this aggregate model. I really enjoyed Ning's talk this morning. That gave me a lot of inspiration for how we can improve this. And that gives us a ranked list of candidate elements. So we took our elements in at the start, all of our candidates, and then it gives us a ranked list of how likely each of them is, according to all of these models, of being the cart page. And then we can perform experiments on the top N of those, depending on the problem we're working on. Okay, so challenges in future research. I've kind of skimmed over a lot of complexity here, right? So, for example, I assumed in this, in that process I showed at the start that there actually is a cart page. Some websites will just take you straight to the checkout page, or everything will be in a little drop-down JavaScript populated menu, which obviously won't yield to this kind of treatment of trying to find a cart button and clicking on it. Not only that, but the finding the button and this particular business case is just one small thing, right? This is just one small task of, hundreds of other sort of potential business use cases that we could be trying to tackle using this kind of web automation framework. And then I alluded when I was talking about the types of data, this kind of action consequence sort of type of data, and trying to leverage this. I tried this expecting this to happen, and then I'm 90% sure that is the thing that happened. And trying to combine predictions and models from all over the place in this process is an interesting challenge, and it's certainly something that we're going to be researching in the future and trying to develop in the future. We're a very new team, by the way. I'm not sure if I mentioned that at the start. The team that I'm in has only existed for about 6 months. So the future research directions that we're planning to take, we want to be looking at kind of these sort of inventive ways of extracting features from the information we've got available to us, trying to use more sophisticated and cutting-edge classification techniques, and start modeling these kind of more complicated workflows, this action-consequence relationship. So one of the things I wanted to impress on you today is that this is a really, really cool problem, and it's really exciting, and it's an awesome team, and we're hiring. So please reach out to me if you're interested in this opportunity, and we can talk about it. So yeah, I mean, that's everything I had today. So I'm happy to take questions now, or if we run out of time, then feel free to reach out to me using these methods here.
We have a minute or two.
Okay.
If there are any questions?
Thanks.